10.4, Summary of the conic sections. When you see a formula, you want to be able to tell which one it is. For instance, down here, you need to see that formula and know that that's a parabola that opens in the x direction specifically, or this one is a parabola that opens in the y direction. So you're looking for, this equation has an x and a y squared in it, or this one has a y and an x squared in it. So we're trying to identify some characteristics that would tell me what this thing looks like. When you see this equation looks like this, you should be able to tell that that's a circle. You should be able to see that the center is at HK and it's got a radius of R. When we look at one of these two, we know that's an ellipse. And notice it tries to specify which number is bigger, right? Whichever number is bigger tells you if it's stretched in the X more or in the Y more. So you've got these other attributes, how to find a focus. Probably should have mentioned that in the hyperbola or in the parabola. You're going to find the focus with that formula, A equals 1 over 4p there. Okay, so don't forget about those extra formulas. With an ellipse, you've got c squared equals a squared minus b squared. And then with a hyperbola looks an awful lot like an ellipse, but you're going to notice this minus sign, okay? So you're going to notice the negative, and I guess according to this, A isn't the bigger one, but A is the one that goes with the positive one. So I don't know that it matters really here, because this formula for finding the focus, you're adding a squared plus b squared. So that's how you're going to find the focus. So you've got all those things, you put those together, you should be able to tell what each of these things looks like. Example 1a, determine the type of conic section represented by the equation and graph it. So when I look at this, the first thing I notice, or the first thing I try to look at, is it's a positive x squared and a positive y squared. So I'm thinking that's probably either going to be a circle or an ellipse. But in order to figure this out, we're going to have to do completing the square. So let's do completing the square the same way that we've done it several times before. So half of negative 4 is negative 2, and you square that as positive 4. But that 4 throws off your equation, so I'm going to come through and subtract 4. So my square is x minus 2 squared. Then we look at the y's, and half of that 2 is a positive 1. Square that is a positive 1. I have a square of y plus 1 squared. So there's the left half of my formula. Oh yeah, that 1 has thrown off my equation. So let's subtract 1. Now here's where this one gets a little bit weird. Negative 4 minus 1 is negative 5. And of course you had this negative 5 over here. So we want to add that 5 over. But that makes 0. So we've got some kind of weird result here. X minus 2 squared plus y plus 1 squared equals 0. Now, normally we would say this is a circle, but that 0 is a strange answer, okay? You can't have a circle with a radius 0. A circle with radius 0 is a point, okay? This is a point. Again, think about a circle of radius 0, and that point would be at x equals 2 and y equals negative 1. This is a point at 2, negative 1. So if they asked me to graph this, and that's what they did, graph it, the point 2, negative 1, that's all it is. So I wish we had a different number over here so that we could have actually had a circle. But this is not a circle. It's a circle with radius 0. That makes it a point. Example 1b, determine the type of conic section and graph it. So we want to try and put it in standard form, and so that means I'm going to add this 16y squared over. I see 9x squared plus 16y squared equals 144. So again, the fact that that's a positive in there, they're both variable terms are positive, tells me that it's either going to be a circle or an ellipse. They're both x squared, y squared. That's not a parabola. They're both squared, so that's either going to be a circle or an ellipse. But it would only be a circle if these two numbers were the same. If they're different, I'm thinking it's going to be an ellipse, and I need the right side equal to 1. So in order to do that, I'm going to divide by 144. We have to simplify a fraction or reduce a fraction, and that involves saying how many times does 9 go into 144. 9 goes into 144 16 times. So that fraction would reduce to x squared over 16. Likewise, 16 goes into 144 9 times. And of course, 144 over 144 is 1. We would see that equation and we should immediately recognize that that's an ellipse. With center as 0, 0. So let's draw our grid, and we want to graph this ellipse. It has a center at 0, 0. And you can see over here from the formula the a value is 4 and the b value is 3. That's coming from the square roots. So in that x direction, the major axis, we're going to go over 4. And in that minor axis, in the y direction, we're going to go up or down 3 from the center. That's going to give us our ellipse with that equation. Example 1c, determine the type of conic section. So when I look at this one, the first thing that I notice is that there's no x squared term. There's an x term and there's a y squared term. So it looks like it's going to be an x equals y squared. It looks like it's going to be a parabola to me. That's what I would guess that's going to be before I even start. So let's rearrange things a bit, I suppose, or actually let's do completing the square. You're going to have this 2x, and then we're going to have to complete the square on the y terms. So y squared minus 10y plus blank. And then just move that 17 way over. Okay, so completing the square, half of the negative 10 is negative 5. Square that's 25. I just threw my equation off by 25, so let's subtract 25. That square, y squared minus 10y plus 25, this part right here is y minus 5 squared. So let's just write down the rest of the equation. We would have 2x plus y minus 5 squared. And then put those two terms together, minus 8 equals 0. So we're going to need to rearrange things, but remember what we want. We want the form that's going to be like x minus 5 or x plus 2 or something like that. So I want the squared term on one side and the everything else on the other, I guess. So actually what I'm going to do is I'm going to subtract this squared term. Over to the other side. So now I have 2x minus 8 equals negative y minus 5 squared. So that looks pretty close to what we want. I don't like that coefficient 2 in front of my x though, so I would factor out a GCF there. And then I would divide by that too. So when you divide over here on the right, notice that's -1. That's going to turn into a -1/2. So that 2 cancels. I've got x minus 4 equals -1/2 times y minus 5 squared. Just like I thought, that's a parabola. That's a parabola with a vertex. Okay, that's a parabola that opens to the left, and the vertex is at 4, 5. So we have to graph that. Okay, if we have to graph that, we're going to 1, 2, 3, 4, 5. And we need to go up to about 7 or 8. This parabola opens left. It has a vertex at 4, 5. So 4, 5 is about right there. And then it's really hard to use your 1, 3, 5 pattern because there's a 1/2 in there. If you think about your 1, 3, 5 pattern, you'd have to cut it in half. So that's kind of hard to graph, but we can try. We go over a half and up or down 1. You go over 1.5 and up or down 1. And then you go over 2.5 and up or down 1. It's going to look something like that. Of course, you can always make a table if you want, if you don't want to use the pattern. Example 1D, determine the type of conic section. So I see an x squared and a y squared, so I know it's not a parabola, but I don't know what else. What I'm going to have to do is that completing the square that I've done so many times before. So take out that -4, and you're going to have x squared plus 6x plus blank. With the y terms, do the same thing. Take out the GCF of 25. You'd have y squared plus 4y plus blank. And then move the 36 over. So that line right there is the exact same as the original problem. I haven't changed anything. I'm going to complete the square over with the x's. Half of the 6 is 3, and square that is 9. So we're looking at x plus 3 squared with a -4 in the front. Over with the y's. Oh, wait. We just messed up our equation. Not by 9, though. We messed it up by -36. And so we're going to add 36 just to keep that thing in balance. So now let's do the y's. Half of 4 is 2. Square that is 4. We have y plus 2 squared with a 25 in the front. I just messed up my equation, not by 4 though, but by 100. And so I'm going to have to subtract 100 to keep my equation in balance. So combine those. 36 minus 100 is -64 equals the 36. When I look at this, I can tell it's a hyperbola because one of the variable terms is negative and the other is positive. Okay, so right now we already know it's going to be a hyperbola. I'm going to do two things in this step. I'm going to add this 64 over, but I'm also going to switch these around. We like the positive term to be first. So if I switch those around, I would have 25 y plus 2 squared minus 4 times x plus 3 squared equals 100. Okay. Now I want this equal to 1. Your standard form is going to be equal to 1, so we're going to divide all terms by 100 and reduce those fractions. So 25 goes into 100 4 times. I see y plus 2 squared over 4. And 4 goes into 125 times. So we have x plus 3 squared over 25 equals 1. There's my equation, and that is a hyperbola. We can see the center is at, look at your x term, negative 3 comma negative 2. And we can tell it opens in the y direction. So let's graph that. We start with our center point at negative 3, negative 2. And then we notice our a number is 2. So we're going to go 2 in the y direction. And we're going to go 5 in the x direction. Draw the rectangle through the points, and then draw your asymptotes. So now we have the boundaries, and you have to do this step. Don't skip this step. Okay, you have to do this because that's what tells you how wide to make your hyperbola curves. So once we have that, we can draw our curves in so that they will curve around and follow those boundary lines. There we go. Example 2, identify the graph. So we see an x squared and a y squared, so we know it's not a parabola, but we really need to do our completing the square to figure out what else is going to happen. So we have, take out the 9, we have 9x squared minus 8x plus blank. Take out the 25. And we have y squared minus 4y plus blank. And then we have equals negative 19. So completing the square, half the negative 8 is negative 4. Square it, that's 16. So that says x minus 4 squared with a 9 in the front. And I've just messed up my equation by 9 times 16. 9 times 16 is 144. So I've messed up my equation by 144. So let's subtract 144 just to keep it in balance. And then on this side, half of negative 4 is negative 2. Square that is 4. We have y minus 2 squared with a 25 in the front. Okay, I just messed up my equation by 100, so we're going to subtract 100. So put those together, that's minus 244 equals negative 19. So I'm going to add this 244 over, and I can tell already what this is. It's going to be an ellipse. You can already tell because it's an x squared plus an x squared. But let's move on. Let's see what we've got. 9 times x minus 4 squared plus 25 times y minus 2 squared equals, if you add that over, you get 225. 225. We would divide by 225 because we want that 1. And then when we simplify, 9 goes into 225 25 times. So we have x minus 4 squared over 25. And 25 goes into 225 9 times. So y minus 2 squared over 9 equals 1. There's our equation. But we can tell that's an ellipse. That's an ellipse with a center at 4, 2. So if you wanted to graph that, okay, I know it didn't tell us to, but if you wanted to, you could graph it 1, 2, 3, 4, 1, 2. We've got a center at 4, 2. And then you go over in the x direction 5. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 this way. And then in the y direction, you're going to go 3. So 1, 2, 3 up, and 1, 2, 3 down. And so there you have it. There's your ellipse with center at 4, 2.